Welcome to our introductory video tutorial for SES CrossSection, a tool for specifying conductor characteristics and their locations. Let's begin with an overview of what we'll be covering. SES CrossSection can be launched from programs like CoreCAD and RoCAD, or, as we'll be using it in this video, it can also be launched as a standalone application. After we've launched SES CrossSection in standalone mode, we'll briefly show how to create a new SES CrossSection project, and then we'll prepare the cross-section configuration for a three-phase transmission line. We'll be defining the phases of that transmission line and specifying the locations of its components. This table provides a summary of some of the characteristics of our transmission line's conductors. The three phases will each be comprised of bundled conductors and will be made of the same type of material, and there will also be two shield wires, or neutrals, which will be of different types. One shield wire will be an optical conductor, and the other will be steel-based. We'll get into more details about how to define these conductor characteristics after we launch the application. So to open SES CrossSection in standalone mode, double-click on the SES software folder here at the upper left of the desktop. Then open the Tools subfolder and double-click on the SES CrossSection icon to start the application. SES CrossSection opens with a new project file, which by default has a generic file name based on the date and time. From the File menu, you can rename your project with the Save As command, or you can create a new project with a new command, which can also be invoked with the keyboard shortcut Ctrl+N. Before proceeding further, we'll highlight some of the various panels that are in the SES CrossSection user interface. At the top, we have the Specifications panel, which includes the Phases and Component Locations tabs. We'll be specifying our transmission line data in this panel. The bottom panel, called the Remaining Issues list, shows useful information such as errors, tasks, warnings, and messages. We'll be creating a cross-section that could later be used with the right-of-way program. So we'll start by choosing the appropriate setting for what's called the configuration mode, which we access by selecting File Options from the File menu. This brings up the Cross-Section Options window. We see that right-of-way is the default value in the configuration mode drop-down menu, but we'll briefly access it anyway just to show quickly that there are other modes available, such as CoreCAD, which we mentioned earlier, SES eBundle, and others. But we'll keep the right-of-way default selection and then close the cross-section options window. The next step is to define the phases of the system. First, a brief word about phases. A phase corresponds to a given energization status, and a given phase can be assigned to multiple conductors, provided that those conductors are expected to have the same potential. So for our example, our two shield wires can be assigned to the same phase, neutral, since both shield wires will normally be unenergized and connected at regular intervals, ensuring that at any location along our transmission line, our two shield wires should be at the same potential. We begin the process of defining our phases by clicking on the Add Phase button 4 times to create the appropriate number of phases, 4. As we see here, these phases will be assigned default names at their creation, phase number 1, phase number 2, and so on. And we're going to rename these. To do this, we simply double-click in the cell in the phase name column containing the default name, and we enter the name that we wish to assign to the phases. Here we're naming them neutral, and then phase A, phase B, and phase C. Our next step is to specify the location and characteristics of the conductors of our transmission line. We'll do this in the Component Locations table. As you may recall from the introduction, our transmission line will have two shield wires, and for one of these, the one that we're going to begin specifying now, we'll use an optical conductor. So our first step is to click on the Add Component button, whereupon a new row will appear in the table above, representing one component of our transmission line, and is given a default name of component number 1, which we'll rename neutral 1. Then we're going to launch SES Library to select a particular type of optical conductor manufactured by Alcoa. To launch SES Library, we double-click in the cell with the component type column, then select Create New, and then From Database. And with this, SES Library will launch. There's a separate video tutorial for SES Library providing an overview of how that application works, and you're invited to consult it for more details. Briefly here, we'll just mention that SES Library opens with the category filter window open, and here we'll be selecting OPT-GW from the conductor class category. And we click OK. SES Library then presents all of the optical conductors in its database, and we're going to select the Alcoa 4848606 conductor. When we click on the Import button, SES Library closes, and we're returned to the Component Locations panel in SES CrossSection, where we can see that the conductor that we just imported from SES Library now appears in the component type column. Now that we've specified the type of conductor for our first shield wire, our next step is to specify its location, and this we'll do in the two columns to the right. When specifying a transmission line in SES cross-section, the value in the Y column typically represents the horizontal distance of the component from the center of the tower, and here we'll enter a value of 10 meters. And for the Z column, representing distance above ground, we enter a value of 39 meters. Next, we assign our neutral 1 component to the neutral phase by making the appropriate selection from the associated phase column. The options we see in this list are comprised of the phase names we specified in the Phases tab earlier in the video. So after assigning this component to the neutral phase, we've now concluded the specification of our first shield wire, and now we're ready to move on to specify the characteristics and location of the second shield wire. We'll follow a similar process, clicking on the Add Component button, changing the default name of the new component to Neutral 2, and again we launch SES Library via the cell in the Component Type column. Only this time we're going to select Steel for the conductor class category. And then from the list of steel conductors, we'll pick a 1-2 extra high strength AG conductor that will import into SES cross-section. And we'll go ahead and assign the location of this component, this time -10 for Y, and again we'll put 39 meters in the Z column. To finalize the specification of this component, which represents our second shield wire, it too will be assigned to the neutral phase. Note that the locations of the two components that we've just specified are indicated in the cross-section display panel located on the right side of this screen. We'll now work on specifying the conductors of phases A, B, and C. As we repeat the same initial steps that we just performed for our neutral components, we recall from the introduction that phases A, B, and C each consist of a bundle of 4 conductors. We won't find that particular configuration in SES Library, so our specification of the components for these phases will involve some manual steps and the use of a template. So after adding a new component for phase A, again we'll double-click the cell in the Component Type column and select Create New, but this time we're choosing From Template and then Bare Conductor. This brings up the Conductor Type Creator window, and it's from this window that we'll again launch SES Library by clicking the Import Conductor button. Now the phase components of our transmission line will use an ACSR Falcon type of conductor, so after setting the conductor class category in SES Library to ACSR, we will select our conductor and import it to SES cross-section. And then we'll modify the generic default conductor name of Bare Conductor to ACSR Falcon. Near the bottom of the Conductor Type Creator window, there's a Replication Details drop-down menu, which is set to none by default. But in order to finish defining our conductor bundle, we need to select the With Replication option. And doing this will bring up several fields. The first field is Pattern Type, for which we'll keep the default value of circular. In the next field, Number of Subconductors, we specify a value of 4. And then for start angle, we enter a value of 45 degrees. The fourth and last field is a bundle radius, and for this we enter a value of 0.3182 meters, equal to 31.82 centimeters. With our replication fields now complete, we click on Apply Changes, whereupon a preview of our bundle will appear in the Component Preview panel. And finally, we click the Create Component button to complete the specification of our component type for Phase A. Returning now to the Component Locations panel, we proceed to enter the coordinates for the Phase A bundle, setting a value of 13.6 meters for the Y coordinate and then 28.5 meters for the Z coordinate. We assign our Phase A component to Phase A, and with this done, we proceed to add our Phase B and Phase C components to our Component Locations table. Both Phases B and C will use the same bundled component type as Phase A, which is that ACSR Falcon component type that we just specified. And because we did, it now appears in the drop-down menu when we double-click on the cell in the Component Type column. We select it, and then set our coordinates for the Phase B component, 0 for the Y coordinate, and 27.6 for Z. Jumping ahead a bit to the third phase component, Component C, we specify its location, negative 13.6 meters for Y, and 28.5 meters for Z, before finally assigning this component to Phase C. The definition of our transmission line is now complete. We note there are no errors or other messages appearing in the remaining issues list, and we see the locations we specified for our 5 transmission line components indicated in the cross-section display on the right. We'll save our project, and the transmission line we've just defined can now be used in RoCAD for eventual import into the right-of-way program. This concludes our introductory video tutorial for SES cross-section. Thank you for watching.